Hello, everybody. Today I want to show you how I am doing agentic coding. I want to focus on coding specifically, go over the different tools that I use, the subscriptions that I pay for, and how I am building with these things. So I have been using them for the last 2 years, and I have gotten a lot of experience with the pitfalls, the pros and cons, and essentially how I manage them to avoid running into the common issues that you see when trying to code with LLMs. Going back to my personal experience, I have been a developer for the last 7 years. I have been coding almost exclusively with agents for the last two and exclusively for the last year. I have basically learned how to code prior to LMs being a thing that anybody had access to. I learned how to code in React and like JavaScript, TypeScript, and Ruby. Ruby was my first language. I was building chess games to try to understand and learn how to code. I want to give a shout out right here to the Odin project. If you're trying to learn how to code, that's the one. That's the place that I learned everything that I know today, and I would highly recommend it. I think it's worth the effort of getting into it. Now, I'm going to share my screen and I will show you guys how this works. So this is a project that I have been working on for the last 2 years. It has been in production for over a year now. It has made money, and I have not gotten hacked. It has not crashed. I have not had any issues with it. It still works to this day, and I have had various iterations on it. So I've done some, and we'll go into what it is in a bit. So this project is a monitor that sits on top of Ethereum type blockchain. So any blockchain that is a fork of Ethereum or similar to Ethereum, and it does the following. It watches the environment, so all of the transactions and a list of accounts, and then it will try to flag what would be a profitable transaction. Once it flags that profitable transaction, it then goes and executes it and then transfers the funds out to another wallet. So it is an automation. And there are multiple components to it that I want to go into right now. For example, you see here, we have the configuration, the database executor monitor, shared configuration bump. So what are these, the reason I'm showing this specifically is to demonstrate how to be more productive with these things, because they have a lot of flaws, right? So one is that you have to kind of curate the context. It's less of a problem now, but when I started automating, it was a huge problem. You had to curate the context for them, and you had to make sure that you give them just enough context that they are productive, but not too much that you basically blow out the context window. Especially back then when, let's say, Sonnet 3.5 in Cursor only had 128K context window. That was very common in general to have models that are like 64 to 128K. I still used them to code back then, but it was a very different way of working. Instead of doing things the way we're doing them here, I would have I would have something like this open. Let's imagine this is Cursor, and then I would have like a conversation and I would copy paste. Eventually they came out with their agent mode, or like their composer mode, which would go and put the code in, and that was the biggest unlock, in that I can just tell it what to do, and typically it can find the right place to make changes and apply the changes. But the context window was a problem, the speed was a problem, the models were not very intelligent, and they would create like tons of slop. Now, this is one project, and what I've learned about agentic coding within this specific project is to use a slice architecture, like modular architectures. Take something that you want to do, right? Let's say you have configuration. Instead of having the configuration spread out the entire repo, have like a single folder or a single file with the configurations written in them, and then have everything else import from that file. And the reason you do that is when you tell Claude, hey, go change my configuration, hey, go change, well, let's just use the voice mode. Hey, go look at my configuration and tell me how this is configured. Don't share any private keys or any sensitive data in your response. So when you have everything that isolated in a single directory or a file, the models themselves, they don't need to do anything complex. They just do a search, they find this is where the configurations are, and then they see everything that they need, and then they can change that in a single place, and it'll propagate to the rest of the application. And this concept obviously applies everywhere, right? So we were talking about configurations, but we can also talk about like the database. So we have the database, we have interfaces, we have the JSON database, and then we have Supabase. So another thing is that you need to be able to test, and testing is super important. So the way I've been building my databases is I will have a wrapper around the database, I'll have an interface for the database, and then I'll have one, whatever it is, the production database that I want to use, and two, a JSON database. And the JSON database is just a file that shares the same structure. And so that way I can see what's going on when I'm making changes. And I found that to be extremely useful. So let's take a look and try to use that. Describe to me how the JSON database works, how the interface works, and how the database wrapper works, and then tell me the differences between it and Supabase. And so I can basically set an environment variable called database, and I can say JSON or Supabase. And then if I say JSON, instead of loading the Supabase DB, it'll just load the JSON DB, and that'll propagate to the rest of the application. And then when I'm working on that application, so I'm interacting, it'll store the data there, right? And this is super useful when you're doing local development or when you're trying to do like staging or whatever it is. You're just trying to like see things without muddying your real data sources. This has been super useful for me. Another thing is that the types are super important. Like having a type system, right? Like TypeScript is very important, but then using the types is super important. So instead of having entities all over the place, just put the actual type itself. Use unknown and then force a type on it. What that does is it helps you keep track of what is going on, reduce duplication, reduce localized like types that start to differ and diverge over the development period. Last thing is to have docs. So I have docs within every single one of my repos, whether that be an agent file inside of each directory. So there's like a recursive agent file system. So you have like the top level agent file, then you have an agent file in each one of the different modules. And that reduces the amount of problems that the models run into significantly, because then they don't have to learn how your repo works from scratch every time. And if you're asking them to make changes, let's say on the front end, and you have the agents MD file, which automatically loads, and then in chat, you have an agents MD. So if you're telling them to change how the chat works, instead of having to load the whole thing again, it'll just like, or you have to teach it the context again, you have your agents file inside of the chat, and that agents file will have all of the details necessary for anybody working within that chat itself. And the model reads that and then applies that. It automatically loads into the model as it is working within a specific directory, which is super useful. So this is something that I've learned over the years, is to have agents files or Claude.md, whatever it is that you use, recursively in every single one of those directories, that you have any module that you can define. So taking it back to tips, you have your repo, you have to break it down logistically into modules. And then each module has to have a type system. And then each module also has to have an agents.md or a Claude.md file. Additionally, if you're working with a database, instead of having just your production database or like a production version and a staging version, you can have your production database and a JSON database, which just implements the interface that you defined, those types that we were talking about. So that's super helpful. Another thing that's been helpful is having LSPs. So while you're coding, like I will open OpenCode right now. Oh man, my OpenCode is having a problem. I'll try to use OpenCode. If it fails, that's fine. But you have an LSP, which is a language server, and it knows all of the different rules related to that language, and you can configure it. And when you can configure it, you can say, don't allow any types. So if there's an any type in my repo, throw an error. Don't throw a warning, throw a full error. And what that does is you have then a model let's say Minimax. Let's do Minimax M2.1. Tell me what warnings are in this repo. So by making it throw an error anytime you do something that you don't like, you are reducing the amount of like nonsense work that you have to consistently do. So you can imagine you set up your LSP, you say, don't allow any files that are over 300 lines of code. Throw an error. And what that'll do is keep your files up to 300 lines of code, And if the model starts spewing more garbage in there, it'll have to break it down into multiple files. And then you can say, don't allow any directories with more than 20 files directly within it, right? And then if a directory starts getting super large, you can have it'll scream at the model and say, hey, you need to break this down into subdirectories, and it'll create subdirectories and move the files in there. And this keeps your environment clean over time. It just keeps cleaning your environment up incrementally over time, and it saves you having to go and say, oh, well, there's an error here. You don't have to do that anymore. You can just trust that your LSP will provide the model the context that it needs, and then you just look at the results at the end. Another thing that I've found to be extremely useful is using Zed. So I have tried Zed many times over the last 2 years, but I finally settled on it as my main IDE for a few reasons. One is having the ability to go between projects that are titled within your code editor is incredible. Like I used to have multiple VS Code projects open, multiple VS Code windows open. I had the terminal, so I had Ghosty open, and I would have like 10 panes on it, which is not reasonable. It's just not reasonable. And the reason it's not reasonable is something that Theo spoke about. So Theo is a YouTuber that does AI stuff, and he spoke about this recently. So you're coding, and then you hear a notification sound, and then which window is it on, right? And then you go to that window, and then by the time you get there and you're doing something, you hear another notification. Which window is it on? Where is your front end open? Where is your back end open? Which one has your whatever your work project is versus a personal project? That gets to be increasingly complex as you scale your attention over to many, many different projects. And you can see here, I am working on 6 at the time. And actually, I'm working on more because within a single project like this one, I would typically have multiple terminals, and each terminal has like some project or task in it. Another thing that I found to be extremely useful is the SSH feature in Zed. So Zed allows you to SSH into a remote repository or a remote device, and it loads that. Like this is my entire file system. You can see it here. This is my Linux machine where my GPUs are running. And so you can see this is like my entire directory, right? You can see everything in here. And that's super helpful. That's super useful. I don't know why VS Code doesn't do that. The VS Code feature for SSH is just completely broken. Going back now to the Zed IDE. So Zed lets you do this thing with ACPs. So ACP is agent, I think it's agent client protocol or something like that. Which allows you to connect your coding modules. So think Claude Code, right? I can open Claude Code, and I get a cursor-like experience. So I'm gonna update this. I get a cursor-like experience for free. I don't have to pay for this. I'm just paying for my Claude Code subscription, and I believe this is actually approved by Anthropic. So this is not something that Anthropic has an issue with. I want to set Sonnet here so I don't have to pay money, but let's do, can you please go and find any documentation or information that is missing, and then create agents.md files in each one of our large modules explaining how they work and the standards of this repository. And we can go and we can watch Claude navigate within the repo. So it's going to be able to find whatever it needs, navigate to the different files. I can watch what it's doing within those files. and I can get that experience that I got with Cursor for free. Cursor is absurdly priced. I think this is incorrect. I think it just did something wrong here, like it deleted, or maybe I'm just imagining it, but yeah, I think it did delete everything here, but that's okay. We'll clean it up after. We don't have to worry about that. But as you can see here, it is giving me that same Cursor experience that I had with the Composer, with a very good model for $200 a month. It has the plan mode. It has everything you need. And this is a open source browser or IDE. It's incredible. Like, I cannot say enough good things about this. And I have a bunch of other things that I can go into real quick. So another thing that I have started using a lot is I am now able to work on about 15 projects at a time. My focus is not super great. I'm not super precise with it, but it is a decent amount of projects. So in order to do that, it's not on all the days. On most days I work between 4 and 8. But on really good days, I'll work on 15 and I'll make some progress, especially if I'm working with Codex. But in order to do that effectively, I need to be able to reduce the time of prompting, of navigating between files, folders, directories, projects, and running long-term processes. And so one thing that I've found to be super useful is I'll run Codex here. Codex is the best model for programming. There's no doubt about it. I can consistently get it to run for 2 to 4 hours without even having to put that much effort in. Instead of typing manually, like me putting in what I want, first I will configure it to always load the model that I like, which right now is 5.3 Codex. It'll always load web search, and it'll always do full permissions, right? I don't want to spend any time on permissions. And I will use something like Super Whisper. So I want you to please review the progress that we've made over the last few days and tell me what this project is at, and do a thorough code review of all the changes we've made against the main branch, and provide me an action plan on what we should do next. Be detailed, be super detail oriented, and output this as a plan.md in the root of the directory. And what this does is I don't have to type. That would have taken me like a few minutes to type. I just hit enter and then I move on to the next project, right? And I do this like in sequence. I'll just go in. All right, let's go. You can go ahead and run it on the GPU that doesn't have any issues as of now. Please make sure to run it on a small model and do the tests for both like the actual full version and the quantized version, and check for perplexity and check for model divergence and check for some benchmark. Use the Olmo model if you can. Thank you. And now I go to the next one, and I just do this in sequence. And what ends up being the problem now is I need to be able to keep a mental model of the code and what's going on within a specific repository. And so one thing that I really, really like doing is create what are called state machine diagrams. So let's go here and create a state machine diagram on our database structure. Please use ASCII and make it detailed just in your response. You don't have to make a file. And I'll push that, and then I'll move on to the next thing. And so this has been one of the most useful things to do is reduce the amount of time I have to spend talking, typing, because that's one of the most annoying things to have to do. And using machine state diagrams lets me have a high level overview of what is going on within a repository. And you can see here that I have a good scan of what this is. It tells me what are the different states that exist. It puts them in a table. And this is a better way for me to maintain a mental model of the code than actually going in and trying to read and understand all of it. I enforce standards. I don't want to waste any time basically reading stuff that isn't important. So if we have our LSP set up and our agents.md telling it how to work, and we give it standards on how it should be acting, then the only thing that's, there's a few things that we can talk about, but the only thing that's left is to have some visual confirmation that what is coming out is actually useful. So the first thing that I'll do with any project is for the main business logic, I will prompt the models to create tests, and I will read the tests, and I will make sure that there is high test coverage. I will make sure that there are integration tests, not just like unit tests, but like full pipeline integration tests where it takes data from one place to another, it outputs a file, and I make it output all of the different steps into a JSON format within like something like data. So there will be like a directory called data, as you can see here, and it has the entire pipeline of like, these are the steps that we took. This is what happened. These are and I'll read all of that code, because what this tells me is if I can get the LSP, the tests, the documentation, the agents.md, and enforce rules that are logical, like don't write any files that are over 300 lines of code. If you do, break it down into multiple files. Don't allow for 20 files in a single directory. If you do, move it into subdirectories. And just having that enforced at every level allows me to get a very fast mental model of whatever is going on within a certain repository without having to read every single line. Now, I do read the code. I read it mostly during pull requests. So at the pull request level, I have to read the code because I need to know, like, okay, what is changing? And then I need to make a change log. But I can also automate the change log. Now, two more things we'll go into before we head out today. Let's see. One is, how do I break down the work? So we have, the model is capable of outputting, right, a lot of stuff. So what we want to do is run the tasks to be as long as possible. So I have this skill called workpack. I don't know if skills, okay, there are skills in here, but this is for open code. But I have a skill called workpack. Let's open it. Codex and /workpack. Oh, skills and workpack. So I have this workpack planner skill, and what it does is I give the model a prompt. I want you to refactor and clean up this repository, removing any duplicate code or anything that is illogical, any stubs that exist, any logic that is no longer used, any duplicate typing. I need you to research first the repo and then turn this into a workpack. So this will go to the model, and the workpack skill will tell it to create a rules file that tells it how to act, right? And the rules file is something that I kind of like, these are the preferences that I like when coding. Scope, which is like the high level overview of what is going on within a single task, and then task files. And each task file tells it like, these are the files that you're touching, this is where you're going to be doing, and this is the expected outcome, and this is the accepted behavior. And now once that's done, now implement, and Codex has a feature, Codex and Pi both have this, which lets you queue messages. So once it creates the files, I can do something like this. So scope.md, yeah, because it's get ignored for now, but I could do scope.md, rules.md, and task00.md. And I can do this. So I put it in, like I queue it. Once it's queued, I do up, and then I do something like this. So I'll switch that 0 to a 1, and I'll keep queuing until I am done with everything. Yeah, I will let it do this. Thanks, whatever. Just to get that out of the way. But I will do that, and then I'll just queue 10 messages up, and the model will do the task. It'll follow the rules, and the rules tell it, don't ask me any questions, don't stop. If you run into a problem, just figure it out yourself, make your own technical decisions, and I can queue that up. And now I have like a 12 to 16 hour run that I can pull off. I don't do this often, but I do this for refactoring. And this is the last thing we'll get into. I refactor 50% of the time. So I will work on new features for 2 days. I will refactor for 3. I'll work on new features for 2, refactor for 3. Usually people will have like 1 day a week where they do tech debt, but this isn't for tech debt. This is for minimizing the amount of code, right? Like the models, they just fucking spam code out there, and we don't want that. We want to have as little files of code as possible so that we can keep a mental model of what is going on. Hopefully this was useful. Thank you guys for watching, and I will see you in the next one.